So we're going to be here. Make sure you have your 10-5 notes out. It is February 2nd, all day long. I purchased a few different coloring books with my own money. So please, if you're looking at these or whatever, like, be careful with them for the Marth class. But I know, like, you had to make a choice, right? So I know more people are probably interested than were able to sign up. These are adult coloring books. I have a bunch of books that are like detailing more information, but this book is all about golden ratio relationships. The golden ratio is the most aesthetically pleasing ratio of length to width, or one dimension to the other dimension. So it goes through Fibonacci spiral is one of the most famous applications of the golden ratio. It also just kind of trips out your eyes. So if you want a cool thing to possibly color, you cannot color my book. But I'm a teacher and I'm allowed to make copies of this. So if you are mastered or if you just want to take stuff home, but if you want to do it here, you need to be mastered. You can look through this, ask me to make copies of pages. I just ask you to stick a Post-it on whatever page you want, and then I'll get it copied as soon as possible. So this is available AO Extensions. I also have a book that is super trippy called Visions of the Universe. And it's like really, like, I mean, even from the beginning, if you let your eyes kind of unfocus and refocus, it can give the page depth, and you can really, like, it turns three-dimensional, especially depending on how you would color these. You could make it really play some visual tricks on people. And if you're in my Marth class, this is some of the stuff that we're going to be doing. Weird spirals that, like, play tricks on your brain. So you could also, if you wanted to, I guess, like, adapt one of these to t-shirt design if you want. You only have a week for that. So check these out. I also have a book all about fractals, and I think you guys know a little bit about fractals from elementary school. So we stopped here yesterday. We just solved the problem with the skier, and we now need to solve this problem. So when we look at this image, the first thing to ask ourselves is, are we working with straight lines? By the way, does anyone need the notes? Anyone not here yesterday? Okay. Are we working with straight lines? So I can identify, I've got this line TYH, that's straight. I've got UYD, that's straight. And YX, well, that's straight, but it doesn't go through the vertex. It starts at the vertex and then just drops down. So we need to relate that 5x to something else. Can anyone take a risk and see where we're going to start to make that relationship? Where the heck are you guys? Not one. Well, I'm looking for your cards. I'm getting all confused. There we go. Oh man, I don't know who raised their hand first. Justin?
Just got a question.
Okay.
Does the right angle apply to both sides?
Ooh. So, if the lines are straight, then what do you think?
Probably.
So, if this makes a right angle, then this also, I wish that was pen, would also make a right angle. And if this line continued up, if we could, like, imagine it, then that would also create a right angle. But I don't know if that's going to let us make that jump. So you identify the right angle. What else do we know about right angles?
90 degrees.
They're 90 degrees. And that right angle here is actually a composition or something made of pieces. So Andrew, what were you thinking, man?
I was thinking they would subtract 40 by 90 because it's in the right angle.
This angle right here, UYH, we can figure that out. Justin and I identified we have a right angle. Andrew identified we can subtract to find out that this angle is going to measure 50. So go ahead and label that angle as 50 degrees. If you want to show the work, show that we did 90 minus 40 to get that 50. Now, oh, cool. Did you kind of make some colors? Oh, I do. I wonder if that'll stay like that. Oh, hey. It makes my writing look fancier. What can I do with that? Well, again, if you're using highlighters, this should help your brain identify relationships. The 50-degree angle. Hey, what colors does that use? What line colors does that use? Green and yellow. Anything else use green and yellow? The 5x. What's that going to let me do? what's that tell me? If they're vertical with each other, that means they're the same. So now we can relate, since this uses the green, yellow, and this uses the green and yellow, we can say that the angle of 5x is equal to 50. And then, Justin, back to you, man.
Another question.
Okay.
Looking at the x and the 5x or the x on the blue line?
We're looking at this 5x as the angle size. So this is saying that this angle is a size of 5x degrees. Aiden, you want to finish this out? We divide by 5, and we get that x is going to be equal to 10. Now again, we don't need the degree symbol on that 10. We can put it if we want, but you don't need it since the degree symbol is already over right there. Any questions on how we did that? I'm going to review the process really quick. This was 90 together. Since it's composed with two angles, I can find my unknown by using what I know. We then relate vertical angles are equal, use our algebra to solve. Any questions? So your friend claims that vertical angles can be acute, right, or obtuse. I need you to make examples of each of these, or if you think your friend doesn't know what they're talking about, make a counter example showing that that doesn't work, that they can't be one of them or whatever. So if your friend is right, we should be able to draw examples of acute vertical angles, right vertical angles, and obtuse vertical angles. And actually, if you're real crafty, you'll only have to draw two different images here. If you're real crafty. Hopefully we remember from what we've seen that if I want to talk about right vertical angles, what's it called when two lines meet in a right angle? We wrote this down the other day. Well, yeah, they are intersecting, but they're intersecting how? It starts with a P. The lines are.
Isn't it like on the top of my head? Isn't it like okay?
So this is really lame. I'm going to preface this with it's super lame. I didn't make it up. A friend of mine, yeah, it's perpendicular. A friend of mine was trying to think about how can I get my students to remember the perpendicular intersection. And so he said, so do you know what a perp is? Somebody that like is breaking the law. They're like, so like from the outsiders, you can think some of those guys would have been thought of as perps because they're like, you know, perpetrators. Perp is short for perpetrators. But one of my friends said, yeah, if there's a perp in my house, I'm going to intersect him right away. It's really lame, but if that helps you remember, perpendicular means that they intersect in right angles. So if this is a right angle, then all of them are right angles, which means this is also a right angle. So are those vertical with each other?
Yeah.
Yeah, because this angle and this angle both use the same two straight lines. They're opposite with each other, so my right angles can work. Now, is anyone confident enough to come up here and draw an example that shows both acute verticals and obtuse verticals in one example? Abby, make it fast. You're way far away back there. And you can color code if you want, or however it will be easiest for you. So this 9.5 minutes, I'm going to check, how well this can hear me from the back of the room. I'm using a different microphone today, so I'm really just talking to fill time so I can go back and look at the video and see, did it pick me up? Will it pick you guys up when you're talking? I got a new camera. It's got a better built-in mic, so I'm trying that out today. So just shoot for that. Okay, so you showed your top and bottom with black angle markings. What size are those? Are they acute or obtuse? these. So you showed these. What is this?
I was like, this little square.
Is that the square for the right angle?
Yeah.
So we already showed the right angle example though. So we can tweak this just a tiny bit though. I can draw the same image as her, except turn one of my lines a tiny bit. Julia?
Well, I'm gonna come up there.
Sure, you want to try it? So she showed vertical angles. But the problem is if she made that intersection right, she showed the same thing we already showed. Ah. Yeah, the alignment's kind of off. So, can anyone explain how Julia is saying this shows both vertical type of angles, obtuse and acute? Xavier?
Well, like, at the, like, top of all of it, you can see how it's
So like this part of it?
yeah.
So what kind of angle? Obtuse, right, or acute? Obtuse. So then does it have a vertical here? Where at? Left, right, or bottom? Yeah, it's kind of hard. If that's the left, then our vertical here would be this one, right? That's our vertical obtuse because they have to be opposite each other. So this angle and this angle are opposite each other, the opposite obtuses. And then I also at the same time create that angle and that angle for vertical acute pairs. So yes, your friend is right. Vertical angles can be any size. Acute, right, or obtuse.
Wait, does mine still work?
Yeah, you showed vertical angles, but if this is a right angle, then all of these are right angles, and you showed this, the same vertical right angles again. So yours is fine, but it didn't show us acute or obtuse because you added the little square. If you didn't have that square and you said, okay, this one's obtuse and this is acute, which looks like it might actually be. You're really close to 90, so that's the problem. But yeah, it will work. It just shows 90 degree
There's no
obtuse.
90 in the other. No right.
In this one, you're right. So this has no right angle. It shows obtuse or acute. So my obtuse here, and I should have really changed color, but my obtuse are the red squiggles down here. And my, sorry, backwards. My acute are the red squiggles. And my obtuse is the green, these angles. No, not in one image. I said if you are able to challenge yourself, you can do it in two. We could do 3 different images. We could break this into 2 different images, but we don't have to. So let's use what we know to figure out some cool relationships here. Because this is going to lead us on to some actual Math 8 standards. Flynn, what if I look at this image? Am I going to know really about any of the angles? You can choose. I would not choose C, E, D, or G down at the bottom. I would stay up at the top. Can you tell me any angle that we know based off that 70 degree? Okay, how do we figure that out? So you said F, right? What do we know about the 70 degree with F together? Is that going to be together? Is the angle acute, right, obtuse, or straight? Straight. What does that mean it measures? 180. So if together they measure 180, how could I figure out what F equals? The what? Yeah, exactly. How do we do that? If we know the whole thing's 180 and this part's 70, we can just take my 180 minus the 70, and that's going to give me 110. So that angle F is 110 degrees. Now we can also figure out some more. Casey. Oh, sorry, I'll give you a second. Maylee, do you know anything else we can figure out? Think about our vertical relationships. Does 70, the 70 degree angle, is that vertical to anything else? What's it vertical to? So we got to use the same 2 straight lines, right? So if I highlight my lines, I've got green and I've got yellow, and then I got to be opposite each other. So if this one's down here, the opposite angle's up here. So angle A, what would we know about angle A? It's the same, which means it measures 70 degrees. And if angle A measures 70, well, and we know F now, so if this is 110, Casey, coming back to you, does the 110 angle that we know have an angle vertical to it? So this should probably help if I get rid of this total arc, because we actually did that to get the 110 here. What angle would be vertical to 110? If we go opposite side, can't go beside, gotta go opposite. So angle B is also gonna measure 110 degrees. Now here's where this gets really cool. If S and S prime are parallel, so we would actually add in a little symbol that would say this is parallel to that, then the relationship we can make, and I would ask that you write these down so you can reference this. Hey Flynn, you can tell you're not with me. Can you be with me, please? If I slid this line down and stacked it on top of S prime, what angles would line up directly on top of each other? Andrew, what do you think? What angles would line up? Like if I slid this down, keeping that transversal, the line that goes diagonal through it, where would angle B land?
Talking about the top line that's blending it down.
Yeah, so B would end up on top of which of these angles? B would end up on top of G, which tells me G is 110 degrees. E is 110 degrees. D is 70 degrees. And C would also be 70 degrees. This is a really cool relationship that happens anytime you have parallel lines. Think about train tracks. Parallel lines, right? And then you have a road that crosses them. This angle will be the same as this angle, which will actually be the same as this angle, which will actually be the same as that angle. I can do the same thing with my obtuse angle is the same as my obtuse angle, is the same as my obtuse angle, and the same as my obtuse angle. This makes your life super easy. Because by knowing one angle, you can figure out everything else. So this is really useful to make your life easier. Any questions? This is a little bit further than what you need to understand, but I think I put a challenge problem on the homework that this will definitely help you. Huh? Is it? Yeah. I thought I put a challenge problem, that's why I put it in the notes. So let's now look at 10-6, some problem solving. I'm going to pass out notes. Anyone ever heard about crop circles? Do you think they're man-made or alien-made? You guys can split those. So, this is kind of a dangerous question to discuss with middle schoolers, but some things in our world are kind of hard to describe. And back in the old days, when they didn't have as much science, they would just attribute all of it to the gods. They would say the gods did it. The god of rain, the god of fire, they had all these different gods to explain stuff. Okay, we now understand there's no sea god. The tide happens because the moon has its own gravity. We understand all the science behind it. But when we don't understand something still today, such as really crazy crop circles, we sometimes attribute it to, who knows, it might be aliens. Because that's a really easy way to not say there's some omnipotent god up there. No, there could be other creatures from other planets that have come to visit and done things to say, hey, we were there. So, that is going to lead us to this example, but we're not there right yet, so hang on to that thought before we get down there. So, my dogs are kind of crazy. And we have our patio door, and then imagine with me that we have a window here and a window there, My house is not actually set up like that. But imagine, that's the back of our house. So we know the back of your house is a straight line. So my dog goes out, buries one bone 53 degrees off this angle. And let's say we had the dog tied up. We can see the rope. We can measure the angle. I don't tap my dogs though. From bone 1 to bone 2, we want to say how many degrees is that? So we're going to use the same techniques that Andrew and Justin just helped us with in the last notes. So, Joe, what do you, like, when you just start looking at this image, what sticks out to you? Yeah, so we know an angle measured here is 53 degrees. We also know something else, actually. New people. Brandon, what else do we know? There's a 90-degree relationship right here, or a right angle. Where's the other one? If this is a straight line, then we know that this is also, and I'm just going to make it really big just so we can still see everything, that's also 90 degrees. How do we figure out the angle from bone 1 to bone 2? Bella, what do you think? How do we figure out this unknown red angle? Yeah, we know our total of 90. We can take away the 53. So if I do 90 degrees minus the 53 degrees, that's going to equal, take away the 50, then take away the 3. We get 37 degrees. Use the relationships that you see to figure out the things that we don't know. Any questions on how we did that? You guys ever seen a railroad crossing sign? So you should recognize that this is pretty much your railroad crossing sign. So this would say, like, you know, this would be an X and it would have like RR crossing or whatever, and below it it'd probably tell you how many tracks it is and if you need to stop or not. This always tricks people up. So I'm going to warn you, think really analytically as we go through this. We want to state whether each of these is a true or false statement. You can work with partners. I'm going to give you a couple minutes to discuss this and decide on it. But the one thing I want you to think about to begin with, 8 angles. What? 8 angles? When I look at that image, at first, all I see is 4 angles. But there are 8 angles in that image. We normally don't go over 180. We like to talk about angles under 180. So I agree, we could, hypothetically, there wouldn't be unlimited, but there'd be a lot. But we most often talk about 180 or less. We try not to go over the straight line, because then you've created an obtuse angle on the other side of that giant angle. You know what I mean? So I don't think everyone's on the same page as Justin and I. He said there's unlimited angles because he's thinking about, I could actually look at an angle that does this, but we most often don't, because we would then look at this angle. So most of the time we stop at the straight angle. So if A is super confusing, skip it and move on to the other ones. But talk with your neighbors, your partners, whatever. Try to figure out true or false on each of these. So. Okay, so you can continue cutting is what you're saying. So then you can combine all those angles into one bigger one. So I agree. If we were able to cut, okay, we could cut this over and over and over and over again and keep making more angles. That's not what they're saying. They're saying using the lines that you have shown, because like if this was the sign and that was the crossing, you're just thinking of the idea of an unlimited angles, right? So it depends on how you name them. Because if you give each one a specific name, it can't, like you could technically talk about an unlimited amount of angles. You can be as small as you want. or we get an angle that's 0.000002 degrees. But that, like, so yes, because so I can point at all the like molecules around me, but if I start trying to name them, I mean, there's essentially now there is a finite number of molecules, right? Because matter can't be created or destroyed. But I could keep creating new angles. So we really could have an infinite amount of angles, so I could keep getting smaller and smaller and smaller and smaller. The idea of infinity is really like, let's say the distance between me and the door. Like we had this talk before. I can walk halfway to the door, and that's one trip. I can again walk halfway to the door, and that's 2 trips. I can walk halfway to the door, and that's 3 trips. And I can keep doing this halfway to the door, halfway to the door. Am I ever going to make it to the door? Not if I only ever go half. If I only ever go half of the distance remaining. Half, then half, then half, then half. I'm barely moving. But now I'd have to be closer to the door. But there's technically an unlimited amount of trips that I could take, since each one is half the size of the one before. So if you think about doing that with angles, cutting angles into half the size before, half the size before, technically we could talk about an unlimited amount of angles. It doesn't matter if you can point at it. It matters if you could name them all. Like, I could say, here's all the numbers. But I can't actually name them all, because once I get up to the biggest number possible, I can go bigger. And I can keep going bigger and bigger and bigger. It's like that pi actually goes on infinitely. The decimal places of pi are still generating. Like, there's no end to pi found yet. And you can look up, there's websites that have pi as far as we've calculated. It's millions of place values. There's a computer system that runs worldwide, that when computers go to sleep, if they're logged to this system, they do the long division to generate more values of pi. It's insane. Andrew?
I think I know why you went at the end of the door.
Yeah.
Because there's an infinite amount of depth.
There's an infinite amount of decimal places, or fractions, if we want to talk about it like that.
Yeah.
Well, you'd eventually get to the door.
Yeah.
Now, theoretically, you'd eventually hit the door, but you can't physically. If I only ever go half the distance, I never actually make it, because I still have half that distance remaining. Because the half is constantly changing how big it is. At the beginning, say I'm 10 feet from the door, my half is 5. But then my half is 2.5. Then my half is 1.25. Then my half is 0.62 whatever, is half of that. Then half of that. But then I'm going such tiny distances, I never get there. So this is where a limit graph comes in. If we said that this is my distance to the door and the amount of trips taken, my distance starts high and I've taken no trips. Then as I take trips, I get closer and closer and closer and closer. This line never actually meets this line. They will get ever closer together, but they'll never technically touch. That's a mathematical idea called a limit. Dude, technically, you never get there. We can't go that deep into this right now, but I'll try to find an article and pass it on to you to help communicate this idea. I'll look up a TED Talk or something for the idea of infinity. It's really out there. Like, mathematicians have struggled with the idea of infinity forever. Like, it's just an idea that is hard to comprehend. Sorry, we got to refocus.
But you don't have a door.
With doorway.
There we go.
Alright, talk Reagan. When we look at, why'd you say yes?
I don't know. I just turned around.
So, Reagan, when we look at this, have you figured out how there's 8 angles here?
When you combine like 3 and 4.
Hey guys, this sort of stuff's on your homework, so you probably want to pay attention. Sorry, go again.
When you combine 3 and 4, 1 and 2, 1 and 3, 4 and 2.
So if I look at just angles 1, 2, 3, 4, I immediately have 4 that are 180 or less. But then Reagan said, combine 3 and 4. How big would that be? If I combine 4 and 2, how big would that be? If I combine 2 and 1, how big would that be? And if I combine 1 and 3, how big would that be? So with my combined angles, what'd you say? It is true. So you could say true with combined. angles, if you want the justification there for how we made that true. A? You want to do B? All right, so if, let me erase this. If 4 is acute, 1 is obtuse. What'd you say there? Why?
Because 4 and 1 are
4 and 1 are vertical, which means they're going to have to be the same. Because 4 and 1 are vertical, they'll have to be equal to each other. Michaela, if angle 2 is 90, which you have to use your imagination here then angle 3 will equal angle 4. What'd you think there? So let's imagine this, right? So I'm going to draw a different sign. And if I have right angle intersections, let's say this is right, because that's your angle 2. If that angle's right, what about angle 3? Since 2 and 3 are vertical with each other, if I know angle 2, what can I say about angle 3? They're the same, so this would also be right. And if angle 3 and angle 4 make a straight line together, if 3 is right, what does 4 have to be? It also has to be right. So then the question, would angle 3 equal angle 4? That's actually true. And actually, if angle 2 is a 90, they're all equal to each other. The whole thing's congruent. Lily, what about if 1 and 3 sum together, they'd be equal to 2 and 4? That is true, because they're both what kind of pairs? They are supplementary. 1 and 3 are supplementary with each other. 2 and 4 are supplementary with each other. And Xavier, what about angles 1 plus 2 minus angles 3 plus 4?
True.
That is true because 1 and 2 are supplementary, make 180. 3 and 4 make 180. So this is really 180 minus 180, which of course equals 0. This is true. Also because the supplementary pairs. Any questions on this? We're all confident with everything we just did? So now, if the measure of angle 2 is 90 degrees, so they've gone ahead and given us our right angle symbol, we need to decide which of these must, be careful, not what could be true, what must always be true. So we're talking about what must always be true, has to happen no matter what. So the first thing it asks me, CJ, help me through this, that angle 1 would have to equal angle 3. Now, I want to make this easier for you guys. Could angle 1 equal angle 3? What do you think, CJ? Yeah. This would be 90, this could be 45, and this could be 45. Do they have to be? No, because we don't know anything about these angles aside from angle 2 must be 90. So this could be true, but not always. So I would write out there not always. Could be true, not necessary. Jack, what about the sum of angles 1 and 3 equaling angle 2?
That's true.
Yeah, why?
Because 45
This is what we can actually call a supplementary triple. We have 3 angles that make the straight line, so together they have to be 180. Take away the 90, 1 and 3 together have to be 90, so this is going to be yes, always. if angle 3 is acute, so let's hypothesize this. If angle 3 is acute, so give me an acute angle that we could make that. What do you think?
So,
30?
30.
So if that was 30, angle 1, they then say, is obtuse. Well, if 3 was 30, what would angle 1 need to be?
30.
Because remember, they have to add up to 180 total. So we already said that angle 1 and 3 have to add up to 90.
It would have to be 150.
You're thinking the total of angle 1 and 2 have to be 150, which you're right, but angle 1 here would be left as 60. Does that make it obtuse?
No.
No, this is actually going to be never. That cannot happen. Any questions? That is a weird one to think through. So imagine it like you had a piece of paper on an edge, like up against a straight edge. So you know that this paper is 90, but I can turn it so my upper angle is less, or so my upper angle is more, and my other angle changes with it. So if you had, like say, this straight line, and I rotate this way, my left angle is getting more small, while my right angle gets larger. If I do the opposite, and my left angle gets bigger, my right angle gets smaller. And ironically, this is the Math 2 homework on angles. Angles of elevation and depression. Which does not mean that your angles are sad. Depression. Elevation goes up, depression goes down. From your horizontal. You've now learned some Math 2 content. Any questions? Or else we can move on to our crop circles. So this is not actually a crop circle. This is a very famous like mound. I don't even know if you'd call it a mound. It's out in one of the deserts. I forget what it's called, so if somebody wants to do some research. This is seriously a satellite picture of the desert that looks like a giant ant, actually. So if you look, it's got the thorax right here, like the abdomen, and then the thorax, the butt. General random fact for you guys, ants are really high in protein. If you're ever in a survival situation, ants are really good to eat, actually, and they taste like lemon. So if you've ever had like a lemon drop or lemon head, they actually taste like that. They're a little bit crunchy, though. Don't eat fire ants. Yes, agreed with that. So, because fire ants will sting you on the way down. You can eat them, but it will be an unenjoyable experience. Or you could roast them first. So, I want to know what we can figure out based off what we see in this image. So take a second, take 30 seconds actually, analyze your image. And also recognize it tells us angle 1 is congruent to angle 2. They're going to be the same measure. So look for what do we know, what can we do with this. And that's 30 seconds. Grace, what's one thing that you see in here that might be useful? Okay, the 86 degrees. What can this 86 degrees relate to? Do you see it, Bella? You kind of just perked up. It relates to the x minus 8. How? They're what? They're vertical, which means that they are...
Good morning. Angelina Hipsley, please come to the office. Angelina Hipsley to the office, please. Thank you.
If they're vertical, they're equal. So go ahead and on your paper set up that those two angles, and if I was you, I would highlight it. Those two angles are vertical, so I can set them equal to each other. I can then, Mr. Braun. Okay.
For the 1 and 2,
Yeah.
equal?
Says what?
For 1 and 2, those are equal?
Yeah, so this angle is the same as this angle.
Oh.
But we can't use that quite yet,
Why?
because we need to find out some more information first. If you don't know what x is yet, how are you going to relate 1 and 2 with anything?
Is x the
X is this angle. So X is the angle opposite that. It's right here. That's X degrees. That's why it's labeled a degree. No, it's not a right angle. So, but I like that you pointed that out because I have X here and I have X here. These X's have to be the same. So, using this equation, how can I solve for my X? What can I do on both sides that will let me get to my solution? Mr. Walker, what can I do to get X by itself? Add 8 to both sides. So we add 8 and add 8. That gives me 92 is equal to X. And now I can fill that in right up here. So now, Justin, do you know how we can relate 1 and 2 with that 92?
No. Actually, yes.
Okay.
Okay. So, I think we can take 92 and divide it by 2
Why?
because they're defined for 2 variables and it's divisible by 2.
So when it tells us, so I'm going to piece this together for the people that aren't in your brain. When it tells us that angle 1 is equal to angle 2, we can give it a different variable and just say, okay, well, then they both equal z or whatever because they're both the same. So what Justin is really setting up, but he's kind of skipping a couple steps because he gets it, is that if I have 2 angles of the same size that equal another angle, we then just divide it by 2 to figure out one single angle. Let me stop picking up pens. I'm just change it right there. And that will give me that z, or the angles 1 and 2, each will measure, what's half of 90? Break this up.
42.
45, then half of 2. Anthony?
X is actually 92.
X is what? Oh, I did the addition wrong. Good catch. Thank you. Trying to work too fast. So this is actually 94, which then divided by 2 makes 47. So be careful with that. I should go back up onto that other slide and change that. I will never tell you that I do not make mistakes. That would be a bold-faced lie. So hang on. Well, yeah, I'm out of time. All right, we'll pick this up tomorrow. We may do a little review activity after we finish this lesson. So please come to class. Hey, I have a big request. Can you please let me know if you have questions on the homework? I would love it if we could go over anything that's giving you trouble. So please email me. Let me know if you have questions on the homework. Yo. Yeah. Oh.